Hi, good morning, my dear students, and once again, welcome to the world of electronics. Our lesson for today is taken from Lesson 2 of Module 2 under ALX 111, which is Electronic Devices, Instruments, and Circuits. The lesson is all about digital multimeter, the operating procedure, safety precautions, and proper maintenance. But before we proceed here, let us first have the unfinished discussion with regards to the analog multimeter. And this is all about the AC voltmeter. AC voltmeter is a test instrument designed to measure AC voltages in kilovolt, volt, millivolt, and microvolts. Voltmeter is provided with its own meter scale. It is printed with red color. So when you are using AC voltmeter, we have to focus at this meter scale. Okay, let us now come to the voltmeter ranges. AC voltmeter, by the way, is provided with 4 voltmeter ranges. These are 1000 volts as the highest range, followed by 250 volts, 50 volts, and 10 volts as the lowest range. When your range selector switch knob is positioned at 1000 volts, we have to read this 10 volts as 1000, 800, 600, 400, and 200. Then focus at this red meter scale. So, what will be the calibration? Again and again, we have to use this formula. Calibration is equal to the range over the number of divisions. The same as what we have at this black meter scale for DC voltmeter and DC ammeter. The number of divisions also is 50 if we are going to count, no? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So there are also 50 divisions. So calibration is equal to range 1000 volts over 50 as the number of divisions. So the quotient now is 20 volts. Meaning to say that this is 20 volts. 0, 20 volts, 40 volts, 60 volts, 80 volts, 100 volts, 120, 140, 160, 180, 200. This is 200. 200 volts, 220, 240, 260, 280, 300, 320, 340, 360, 380, 400. So this 4 is read as 400 volts. Okay. So, let us have some exercises. How about if the pointer position here? Focus at this red meter scale. So, it is just between 400 and 300 because between 2 and 4 is 3 and it is read as 300. So, this is 300, this is 400. Then the calibration for every division is 20. So, 300, 320, 340, 360. So, this is 360 volts. Okay? Or, how about here? This one here. Focus at this red meter scale. So, it is just between 800 and 600. So, this means that this is 700. So, this is 720 volts. How about if the division pointer is set to this middle scale between the 2 divisions? So, it is just between 400 and 600 volts. 400 and 600 volts. So, this is 500 volts. So, again, 400 plus 20 volts as the calibration is 420, 440, 460, 480. So, it is just between 460 and 480, and that is 470 volts because half of 20 as the calibration is 10 volts. Or it depends upon your estimation. If it is lower than the middle scale, so you can rate that one as 460, that is 480, so 470. You can have 463, somewhat like that, 465, no? That depends upon your vision or the clarity of your eyes. Because we are only up to estimation kasi. Okay, let us now proceed to 250 volts. With 250 volts range, so again, focus at this red meter scale. 250 is read as 250 volts. 200 volts, 150 volts, 100 volts, 50 volts. Then this is between 50 and 0 is 25 volts. Between 150 is 75 volts. Between 150 and 100 is 125 volts. Between 200 and 150 is 175 volts. Between 250 and 200 is 225 volts. So with this range 250 divided by the number of division 50, meaning the calibration now is 5 volts. 5 volts. So with 250 we have here 50, 25, 20, 15, 10, 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So on and so forth until it reaches to 250 volts. With this range, we need to say that the maximum voltage that could be measured by that range is only up to 250. Beyond that, the 250 volts is no longer applicable. You have to proceed to 1000 volts if in case the voltage exceeds 250. Okay? Now, let us come to reading. So, if the depiction pointer position at this division here, again, 250, 200, 150, 155, 160, 165, 170. Because this is 175, 180, 185, 190, 195, 200. So this is 170 volts. Okay? How about if the pointer moves a little bit from the division here? So, 155, 160, 165, 170. It is just between 170 and 175. Remember that half of 2.5 as the calibration is, half of 5 volts as the calibration for this 250 is 2.5. Okay? So, we have to add 2.5. 155, 160, 165, 170. It is between 170 and 175. So, it is 172.5 volts. Okay? Okay, let us now proceed to 50. We have here 50, 40 volts, 30 volts, 20 volts, 10 volts. Okay? Where is 50? Because the number of divisions here is 50 and the range is 50. So, the calibration is 1 volt. Because 50 volts as the range divided by 50 as the number of division is 1 volt as the calibration or ang halaga ng bawat guhit. So, we have here 10, 20, 30 volts, 40 volts. Meaning, between 10 and 0 is 5 volts. 4, 3, 2, 1. 1 volt, 2 volts, 3 volts, 4 volts, 5 volts, 6, 7, 8, 9, 10 volts. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 volts. So on and so forth until it reaches to 50 volts. Okay, if the pointer is positioned at this division here, it is read as, because this is 30, 31, 32, 33 volts. Okay, 33 volts. How about if the pointer is positioned at the middle of the two divisions here? It is between, because 10, 11, 12, 13, 14, 15. So between 13 and 14, it is 13.5 volts. Because half of 1 volt as the calibration is 0.5. So, just add 0.5. 11, 12, 13. 13.5 volts. Okay? Okay, let us now proceed to the lowest range. If the amount of the voltage that you are going to measure is somewhere at 0 to 10 volts, so we have to use the lowest range, 10 volts. With 10 volts, we have here 10, 8, 6, 4, 2. So, meaning to say this is 2 volts. This is 1 volt. Then this is 3 volts. This is 5 volts between 4 and 6. 7, 9 volts. Okay? Meaning to say that the calibration there is 0.2. Because calibration is equal to range 10 volts over 50. The calibration is 0.2 volt. The quotient there is 0.2 volts. So meaning to say 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2 volts, so on and so forth until it reaches to 10 volts. If the pointer is positioned here, focus at this red meter scale, it is 8, 8.2, 8.4, 8.6 volts. Okay? Or if the pointer is positioned at the middle of these two divisions here, because this is between 4 and 6 is 5. 5.2. 5 volts, then 5.2 volts. It is between the two divisions, between 5 and 5.2 is 5.1 volt. Okay? Okay, that's all. Then, how do we use AC voltmeter? So, just set here, for example, you are using 250 volts to measure the voltage at this outlet. Remember, with AC voltmeter, there is no fixed polarity. That doesn't mean to say nga walang polarity sa AC. There is polarities. But, due to the velocity of the variation of the voltage, so there is no fixed polarity. We cannot tell that this is negative, this is positive. Because the polarities change 60 times in 1 second. There is reversals in polarity. Positive, negative, negative, positive, positive, negative. So the polarity changes 60 times in 1 second. That's why, when you measure the voltage, just insert here. Okay. It reads 245, 230. Okay. Because this is, you are using 250. 250 and 200 is 225 middle. This is 200 somewhere here. 200, 250, 225. So 230 volts. Okay? Or you can use 1000 volts. With 1000, remove first the test rod from the outlet. Change the range to 1000. Then, insert. So this is, you are using 1000 here. So it is somewhere here. Somewhere here. Between 400 and 200, between 400 and 200 is 300. So this is somewhere here. It is somewhere here. 200, 220, 240, it is somewhere here. It is just between 200, 220, and 240 is 230. Okay? You can use either of these ranges because the most accurate reading is when the pointer position at almost middle scale. Select a range, whether it is ammeter, ohmmeter, and voltmeter AC or DC. Choose an appropriate range that could deflect the pointer at almost middle scale, because the easiest way of reading is when the pointer is positioned to the middle scale, and the most accurate one also is almost at the middle scale when using analog multimeter. Okay? That's all for the analog multimeter. Let us now proceed to digital multimeter. Digital multimeter is an advanced version of analog multimeter, and it is equipped with advanced features also. Advanced feature, no? Because digital multimeter based from this brand Sanwa, made in Japan. The model number is CD800A. Is capable of measuring frequency. Then it can also capable of measuring AC current. Also, it is equipped with meter, which is capacitance meter, which the analog multimeter doesn't have. Okay? It is also equipped with range selector switch. It is also equipped with the range selector. Okay? With additional buttons here. Then, the two test parts are permanently connected to the housing of this digital multimeter. We have heard the positive test rod and the negative test rod. By the way, unlike the analog multimeter, when you are using ohmmeter, this red test rod should be negative because it is connected to the negative side of the battery with respect to the black test rod connected to the positive side. But in the case of digital multimeter, this red is already the positive side, and this black is already the negative side, although you are at the ammeter. Okay? We have here the off position. After the tester is used, the range selector switch should be positioned here. Okay? That is to avoid risk and also power consumption of the battery, of course, because this multimeter is also equipped with battery. There are two dry cells, 1.5 volts each, no? Which is a supply to the circuit. So the battery here for this digital multimeter is not only used for the ohmmeter, but to the entire circuit of the meter movements. Okay? It is also used for voltmeter, ammeter, capacitance meter, because it uses common circuit. We have here a microprocessor circuit, no? Used by the meters here. So, it needs supply voltage all the time. To provide voltage also to this LCD screen that displays the value, no? This is the LCD screen used by the digital multimeter together with the microprocessor circuit. Okay? Now, how do we use this V or voltage? So, under V, it has through two meters. We have the DC voltmeter. We have heard DC voltmeter, the symbol is DC. Then, to select, because if you are measuring AC volts, you have to set it to AC. We have our AC symbol for measuring AC volts. But if in case you are measuring DC volts, you have to set the select button to DC. Okay? Then, when you are at this yellow color, there are parameters to be processed or to be measured. Ohmmeter, mega ohm. That is when you are measuring the resistance of the resistor. Okay? Maybe here. That is 3.244. Or you may use the hold button here. For example. Just like that. Okay. The purpose of the hold button here is to stop the movement of the number. So it should be set in such a way that you can clearly read the value displayed on the screen. You have to press the hold button in such a way that it stops the movement. Although the test plugs are no longer connected to the resistor device, the value there is permanently displayed. The resistance there is 3.243 kilo ohms. No? Okay. You can also change then, to remove this value, you have to press again the hold. Okay. You can actually change the unit, no? Unit, ohms, kilo ohms, mega ohms. Anyway, it automatically displays the unit, mega ohms, kilo ohms, ohms, no? As long as you are measuring the resistance of any of the component, resistor, inductor, ECR, transistor, just like that, no? So, anyway, it takes a little longer time before the number is displayed. That is the main disadvantage of using digital multimeter. But the advantage here is that it can display or measure the accurate reading also. Okay. Then, aside from ohmmeter, you can also set this one to by pressing the select. V. What is that V? That V here, this V here actually is voltage. There is a symbol at the uppermost portion here, diode. Meaning to say, it measures the biasing voltage of a diode. No? It measures a biasing voltage of a diode. Okay, we have here. You can, by measuring the biasing voltage, we can also identify whether the diode is a germanium diode or silicon diode. Okay, using this range here. There is a symbol diode here, and the unit is voltage. Okay, we have here a diode, a crystal diode. Okay, it is 0.627 volts. That is now the biasing voltage of the diode. And this diode now actually is a silicon diode. Because if it is inverted, it is reverse bias. There is no reading indicated, meaning it is reverse bias for a diode. But once there is a displayed reading here, it is forward bias. This is now the cathode, which is negative, and this is the anode, which is positive for this digital multimeter. Okay, this is silicon. But how about this diode here? So, reverse bias, there is no reflection. How about here? Forward bias, 0.218 volts. So, we need to say this is germanium diode. Because germanium diode, the biasing voltage there is ranging from 0.1 volts up to 0.3 volts. Whereas for silicon, it is ranging from 0.5 volts to 0.7 volts. Okay. So this meter is used to measure the biasing voltage of a diode, whether the diode is still good or bad. Also, you can identify the type of semiconductor materials being used in manufacturing this diode, whether it is silicon or germanium. No? Okay. How about this, another range here? So, this is for continuity testing. Because when you short the test rods, it sounds. There is a buzzer sound. You can use this one for continuity testing. We have here. This is to determine whether there is no open terminal of this alligator's clip. Okay? So, it's all about continuity testing. When it sounds, there is a buzzer sound, meaning to say that there is continuity, there is no open terminal. No? You can use this one for testing the continuity of the wires. Okay? How about the other range here? Just press this one again. Nanofarad, smaller unit of capacitor. Farad, microfarad, nanofarad, picofarad are units for capacitance. Capacitance is an electrical amount of capacitor. We have here capacitors here. Capacitor with capacitances printed on the body of these capacitors in picofarad, microfarad, nanofarad, and farad. So, the indicated unit here is nanofarad. Okay, let us try to be sure. For example, this capacitor, electrolytic capacitor. Okay. You have here. Hmm, 10.07 microfarad or 10.08 microfarad. That is now the capacitance. Then, there is an indicated value here. This is 10 microfarad. No? There is indicated capacitance here. 10 microfarad. We have here 10 microfarad. The value indicated on the body. This is now the measured 10 microfarad. No? The maximum capacitance that could be measured with this range is only up to 100 microfarad. Beyond that capacitance, this capacitance meter is no longer applicable. Okay, we have here. The capacitance here is 470 microfarad. It cannot indicate the correct amount. Because the maximum capacitance here, where the capacitance meter is capable, is only up to 100, and this is 470 microfarad. So you can't use this capacitance meter anymore when the capacitance is beyond 100 microfarad. Okay? Then we have here the hertz, the frequency. The frequency is applicable only when you are measuring the voltage, when the output voltage is AC. But with DC, the frequency is 0. Okay? We have here, for example, for this outlet, we have here 60.1 hertz. That is now the frequency of the AC voltage. 230 volts outputted by this outlet, provided by the electric company, the Solico. The voltage being measured here is 230 volts a while ago. Now the frequency is 60 hertz. You can connect in either polarity because there is no fixed polarity with AC volts, no? Okay. Or, it is not only intended for measuring the frequency of this outlet, but when you come to the electronic circuits of digital TV, DVD player, or any electronic circuit that processes AC signal, there are lots of AC signal there with different frequencies. So this multimeter is applicable in that case. Okay? Then, of course, we have here the ammeter. This is ammeter DC. Then, when you press the select AC, just in case the circuit is supplied with AC volts, then the current circulating in the circuit is also AC. So, AC ammeter here is applicable for measuring the AC current. But when the circuit is supplied with DC, just like supplied with battery as the origin of DC volts, or the voltage of the cellular phone as the source of the circuit there of the cell phone is DC, so set to DC. We have heard the DC symbol for ammeter. Okay? So, by the way, the maximum current that could be measured by this ammeter, both DC and AC, is only 400 milliamperes. 400 milliamperes. No, we have here 400 milliamperes. Then, for the voltmeter, both AC and DC, the maximum voltage is only 600 volts. If the amount of the voltage that you are going to measure is 700, then this voltmeter is no longer applicable. Okay? I think that's all. So, the difference between analog and digital multimeter, the analog multimeter is susceptible to magnetic field of a nearby magnet, because it uses inductive circuit. When we say inductive circuit, it has a coil, specifically the moving coil used by the deflection pointer, and a magnet. But with regards to digital multimeter, it doesn't have an inductive circuit that will be affected by the magnetic field. Although it is close to a certain magnet, but still the reading is not affected because it is not sensitive or susceptible to magnetic field. Then, there is no problem with parallax error. When we say parallax error, when you are using analog multimeter, your eye should be perpendicular to the meter scale. It is not sidewise, left or right side, as it causes error in reading. But whereas here, since the parameters or the quantities or the value or the reading are displayed digitally, so numerically, no? So, it is accurate. There is no parallax error here. There is no parallax error. Although you are at the side here or at the right side here, it's still the same reading, of course. Then there is no zero set screw to set the meter at the zero scale. Then there is no zero ohm adjustment. There is automatic adjustment of the resistance. No? Okay. Then, of course, before you use the digital multimeter or the analog multimeter, you have to check first the battery. Because there is a lifespan of battery, especially if it is prone to uses. You're always using the multimeter, so there is power consumption. I think the maximum lifespan of the battery is only 1 year. So, before the end of the year, you have to check the voltage, no? The analog multimeter is equipped with battery tester. We have here a battery tester, no? Here, over here. To measure the voltage, it is only for 1.5 volts. Only for 1.5 volts. For example, we have here okay. Okay. You have here. It is still good because it reaches to the blue color. No? It reaches to the blue color we have here. This battery is still good. But with this battery probably it is longer reaching to the blue color. It is between blue and red. Meaning to say this battery or this dry cell AA is no longer applicable. It is very low voltage. No? Okay. That is for battery testing. I think that's all for now. That will be the last part of our lesson. That will be the last topic actually for the electronic devices, for the instrument topic. No? Probably by next meeting we will be proceeding to the oscilloscope, inductance meter, and other test instruments. Okay? Okay. Goodbye, class, and thank you for your attendance.